Assalamualaikum warahmatullahi wabarakatuh and hi everyone. So today I will tell about the Six Sigma DMAIC, which it is stand for Define, Measure, Analyze, Improve and Control. So before we start, I will introduce myself. So my name is Mior Raihan Fitrani bin Muhammad Kamal Baharim. My ID number is MA240N7. So this subject under Professor Madya Technologies, Dr. Haji Muhammad Haji Matno, Faculty of Mechanical and Automotive Engineering Technology, FTKMA, in University Malaysia Pahang Al Sultan Abdullah, UMPSA. Okay, let's go through to the Six Sigma introduction. Okay, before discuss about the DMAIC, let's first understand what is Six Sigma and why it is important to the quality management. Okay, let's focus on the left side. On the left side, we can see the definition of the Six Sigma. Basically, Six Sigma is a data-driven methodology that focuses on reducing defects, minimizing variation, and improving process performance. The target symbol represents the goal of achieving process excellence. Instead of relying on assumption, Six Sigma use facts and data to solve the problem and improve the quality. On the top right, we can see the Six Sigma quality level that represented by the normal distribution curve. The center of the curve represents the process mean, while the sigma level show the variation from the target. At the Six Sigma performance, a process produces only 3.4 defects per million opportunities, which is considered a world-class quality. So this means the process is highly consistent and produce very few errors. And then we can look at the history and development. The timeline shows the development of Six Sigma. It was first developed by Motorola during 1980s to improve the product quality. In the 1990s, General Electric under Jack Webb adopted Six Sigma and achieved a significant cost saving. During 2000s, many industries began using Six Sigma, and today it is recognized globally as a quality improvement standard. And at the below we can see the benefits. So it is highlight the major benefits of the Six Sigma. The organization can achieve higher quality product, lower operating costs, improve efficiency, better customer satisfaction, and continuous improvement. So these benefits help company remain competitive in today's market. Okay, now that we understand the Six Sigma, let's look at the strategy behind the implementations of the Six Sigma. Okay, let's focus on the left side, which is strategy focus. It represents the five key strategy focus. Okay, the first one is the customer focus, which ensure product and service meet customer expectation. The second is data-driven decision making, where the organization use measurable data to guide improvement effort. The third one is continuous improvement, which encourage organization to consistently eliminate waste and improve performance. The fourth is reducing process variation, since the variation often leads to defect and inconsistent quality. And for the final focus is optimizing both cost and quality simultaneously. And then we have Six Sigma strategy framework. The circular diagram illustrates how different elements work together. Customer focus helps define quality requirement. Data and fact provide objective information for decision making. Process improvement use DMAIC to improve performance. People and culture ensure employee improvement and commitment. Finally, result and value represent the measurable business benefits achieved. And then we have The target symbol on the right highlight the overall strategic goal. The goal is not only defect reduction, but also achieving sustainable business performance and operational excellence. And then we have Six Sigma organizational structure. The pyramid shows the Six Sigma organization structure. At the top, it's the champion who provide the leadership and resources. Below of it is a master black belt who guide the mentor improvement project. Black belt lead major Six Sigma project. Green belt support improvement activities within the department. And finally, all the employees contribute to continuous improvement. And then we have strategy benefits. It is include the higher quality, lower cost, improved efficiency, increased customer satisfaction, and sustainable growth. So these outcomes demonstrate why many organizations invest in Six Sigma programs. Okay, we move to the first phase of the DMAIC, which is define phase. Okay, the define phase is the first stage of the DMAIC, and the focus is on the understanding the problem and setting project objective. Okay, let's focus on the project charter. This document provides essential project information, including the project title, problem statement, business impact, goals, team member, timeline, and project sponsor. For the example, the problem statement identifies a high defect rate in the assembly process, while the goal aims to reduce defect within a specific time frame. And for the cycle diagram, it stands for the supplier, inputs, process, outputs, and customer. Supplier provide the material for information. Inputs are the resources needed for the process. The process represents the activities performed. Outputs are the final result produced. Customer receive the output and evaluate the quality. This diagram helps the team to understand the entire process at a high level. And then we have the problem identification. It explains the key issue being addressed. For the example, high defect rate, cost reward, increased cost, longer lead time, and customer dissatisfaction. Understanding the impact helps justify the improvement of the project. And then we have SMART goal. The SMART goal framework ensures goals are well defined. Specific means clearly identifying the objective. Measurable allows progress to be tracked. Achievable ensures the goal is realistic. Relevant align the project with the business objective. Time bound sets a clear deadline. And then we have the voice of customer, which is VOC. It translates the customer requirement into the measurable quality characteristic. For the example, customer want high quality product and on-time delivery. So these expectations are converted into specific process requirement. And then we have the process scope. This defines which part of the process are included in the project and which are excluded. So this prevents the project from becoming too large and difficult to manage. Okay, next we move to the second phase, which is measure. The next step is measure the current performance. Okay, let's take a look at the data collection. The first activity is state the reliable data that gather using observation, chat sheets, interviews, and historical record. Accurate data is essential because incorrect data can lead to incorrect decision. And in the center, we have process map. The process map illustrates the current workflow. It shows how the material move from the component receipt through assembly, inspection, and final dispatch. So this helps identify where the defect may occur. And then we have the baseline performance. The baseline performance table provides the current process performance. For example, the defect rate is 85,000. defect per million opportunities, and the Six Sigma level is only 3.2 sigma. So this value establishes the starting point before improvement are made. And then we have the KPI table. The KPI table explains the key performance indicator. Defect rate measure the percentage of defective units. TPMO measure defect per million opportunities. FPY or first pass year measure the percentage of product passing inspection without rework. Cycle time measure how long the process takes. So this indicator help evaluate the process performance. And then we have the measurement system analysis, or also we call MSA. This verifies that measurement system is reliable. Tests such as gauge RNR, bias linearity, and stability ensure the collected data is accurate and trustworthy. And then we have the data defect analysis. The pie chart shows the distribution of the defect. This alignment is the largest contributor, accounting for 38% of total defect. So this suggests that improvement effort should focus on addressing alignment issue first. Okay, the next one is the analyze phase. Okay, next I will explain the analyze phase in DMAIC. The main objective of this phase is to identify and verify the root cause of defect by using data analysis and quality tools. Okay, first we can look at the left section, which is the Pareto analysis chart. So this chart helps us to identify which defect contribute to the most to the problem. So based on the graph, dimensional defect record the highest number of defect, which is 150 cases, contributing around 45% of the total defects. Surface defect are the second highest, followed by the assembly defect, material defect, and other. According to the focus, according to the Pareto principle, mm, we focus on the bigger few instead of the trivial many. Therefore, dimensional defect become the main area for improvement. And then we have the fishbone diagram, or also called the cause and effect diagram. So this tool helps us to organize possible causes of the defect into a several category. Under machine factor, possible causes include worn-out tools and machine misalignment. Under factor, we have improper setup and incorrect process. Material factor include poor quality material and specification error. Other factors also come from manpower, measurement, and environment. Then, at the bottom, we have the root cause verification. So this table is used to check whether the suspected cause are actual cause of the problem. From the analysis, we found that worn-out cutting tools are exceed the allowable limit and improper machine setup had incorrect settings. So these were confirmed as the main root cause. So overall, in the analysis phase, we successfully identified the key cause of the defect that need to be solved in the next stage. Next is improve phase. After identifying the root cause, we move to the improve phase. The objective of the phase is to implement and validate solution that can be eliminate the cause of the defect. Okay, first on the left side, under solution implemented, several actions were carried out. The first action is replacing worn-out cutting tools with a new high precision tools. So this helps improve machining accuracy. For the second action is machine realignment, where machine components are adjusted and aligned correctly to reduce dimensional error. For the third action is operator training. Employees were trained to follow the proper procedure and standard work instruction. The fourth action is implementing standardized setup procedure using a checklist to ensure the machine setup process is consistent. And next, in the center section, you can see the result after improvement chart. The graph compare defect frequency before and after improvement. We can clearly see that defect number decreased significantly after implementing the solution. The table below also show the performance if improvement. Total defect reduced from 1000 to 243 defect, which is about a 74% reduction. The sigma level improved from 2.8 sigma to 4.6 sigma, while cycle time and quality cost also decreased. And then the key improvement include the increased process stability, reduced defect, improved precision, and better customer satisfaction. So we can conclude that the implemented solution successfully improved the process performance. This is the last phase of the DMAIC, which is the control phase. Control phase. The objective of this phase is to maintain the improvement and ensure the same problem do not happen again. Okay, let's take a look on the top left. You can see the process monitoring section, which use a control chart. The control chart helps us to monitor the process stability over time. We have the upper control limit, lower control limit, and the center line. Since all points remain within the control limit, so this indicates that the process is stable and under control. And then we have the standardization activities. Several actions are implemented such as updating standard operating procedure, preparing work instruction, conducting employee training, and improving the documentation. So this ensures that everyone follow the same process. Moving on to the below section, the control plan table show what needs to be monitored. For example, machining process monitor tool wear, assembly process monitor dimensional accuracy, and environmental factor monitor the temperature and humidity. Responsibilities and corrective action are also assigned. Then you can see the continuous improvement culture. The organization should encourage employee feedback, review performance regularly, identify future improvement opportunities, and continue focusing on customer satisfaction. Therefore, the control phase ensure the improvement are maintained and sustained over a long period. And now we are already in our conclusion. And finally, our conclusion. So let's look at on the left side under project summary. We can see the overall DMAIC process. We start with a define by identifying the problem and customer requirement. Then measure was used to collect process data, analyze, help identify the root cause, improve, focus on the implementing solution, and finally control, ensure that improvement were maintained. Next, the key result achieved table show the impact of the project. Total defect reduced from 1000 to 243, which is a 74% reduction. Sigma level improved significantly and customer complaint also decreased. And then we have the impact on organization that show the several benefits achieved, including the improved quality, cost saving, increased customer satisfaction, operational excellence, and sustainable improvement. And then we have the before and after comparison at the bottom, which is it clearly show the overall process improvement. Before the AIC implementation, the process had high defect and instability. After the implementation, the process became more stable with lower defect and better quality performance. So, in our conclusion, Six Sigma DMAIC is a systematic and effective methodology that help the organization reduce defect, improve quality, and achieve continuous improvement. Okay, that's all from me for the Six Sigma DMAIC. Thank you for watching. Bye bye.